So I'm going to find the domain of this graph. Remember, domain are our x values, so I have a closed point at 2, which is going to give me a bracket, and then we go all the way out here to 22. So my domain are all the x values that are covered 2 to 22. For our range, we're looking at the height of the graph, so we say our lowest y value covered is 1, and there is a point there, so it gets a bracket, and the highest y value that is covered is 10, and there is a point there, so it gets a bracket. We're talking about minimums. These are our lowest points on the graph, so we do here, here, and here. Our absolute minimum is going to be the lowest point, so that would be 22, 1, while our relative mins would be 0, 2, and 7, 4. Our maximums here and here. For these maximums, we say our relative would be 3, 4. For our absolute max would be 9, 10. Remember, when we check for increasing, we're going to trace our graph and see where our pencils are going up. And these are all x values that we're going to be evaluating here. So we're increasing from 0 to 3. And then we're also increasing from 7 to 9. For decreasing, this is where the graph is going downhill. So that is from here to here. So for this one, we will be decreasing, again from here, these were increasing. We'll be decreasing from 9 to 22. The next part, we are checking to see if this is a function or not. Remember, if our x values repeat, then it is not a function. As I go through the list, -7 does not repeat, 3 does not repeat, 0 does not repeat, -2, -6. So yes, this is a function. We're only caring about our x values. Nothing repeats, so yes, this is a function. If I have a graph, remember I'm running a straight line test. This is touching twice, which means no, it is not a function. I want to check each point here to see if any of my x values are going to repeat themselves. And because they don't, this is, yes, it is a function. For this last one, we're looking at, on this page, function notation. So remember, we're using the graph f of x. In this problem, the 1 replaced the x, so we got to where x is equal to 1, and the y value is 0. Now for this one, we notice that our y value is what's given to us. We're looking for x, so we go up to where y equals 7, and we find it on our graph, and that is going to be right here. Like we can check and see, it does not touch anywhere else, and so that x value is -10. For this problem, our y value is -2. That's here. We notice that -2 happens 3 times. So we have to list each of those x values. -7, -3, and 6. This one, we were given the x value is 8. So we come out to where 8 is. And we see that the y value that goes with 8 is 0. Flipping to the last page. I'm given these 3 functions, f of x, g of x, and h of x. And so we're going to use this like a roadmap. Because I see f of 6, I know I'm going to use this first equation. The 6 replaces the x, so I'll plug in 5 times 6 minus 10. So 30 minus 10 will give me 20. For this one, I'm using h, which is here. I notice that the -3 replaced the x. So 2 times -3 plus 6. That's positive 6 plus 6, which gives me an answer of 12. Then I see the problem g, so I'm going to use this equation. 4 replace the x. So I'm looking at 10 times 2 to the 4th power. I'll plug that into my calculator, and it's going to give me 160. Here again, I see g of -2, so I'll plug in 10 times 2 to the -2 power. and that's going to give me 5 halves. If you want to turn that into a decimal, 2.5, I'm fine with that as well. Now for this one, I'm using f of x, but I'm finding x, so I need to take the equation 5x minus 10 and set it equal to 10. Then I just solve for x. 5x will equal 20, which gives me x to equal 4. See this one, I'm using h again, and the h equation is going to be set equal to negative 3. So negative 2x plus 6 is going to equal negative 3. Subtract 6 from each side. Negative 2x is equal to negative 9, which gives me x is equal to 9 halves, or if you're turning this into a decimal, 4.5. These next problems, we're just going to solve each equation. So the first thing I got to get rid of is my 3. I'm going to subtract 3 from each side. So we have x over 6 is going to be equal to negative 8. We're going to multiply each side by 6. These cancel, so x is equal to negative 48. 72, same type deal. We're going to start by getting rid of the 6. So I have 5x over 2 is going to equal to 15. Multiply each side by 2. So 5x will equal 30. Divide each side by 5. X equals 6. Start by adding 4 to each side. So we have 3x minus 2 equals, or over 5 is going to equal 11. We got to get rid of the 5 in the denominator, so we multiply each side by 5. We get 3x minus 2 is going to be equal to 55. Add 2 to each side. 3x equals 57. Divide each side by 3. X will equal 19. For 74, we want to get rid of the 6 in the denominator first. Multiply each side by 6. 2x plus 4 will equal negative 24. Subtract 4 from each side. 2x equals negative 28. Divide each side by 2. X will equal negative 14. We have 4 options for 75. Whatever you want to do first will be fine. I'm going to subtract the 3x to try and combine like terms. So I have 6x plus 6 is going to equal negative 15. I'm going to subtract 6 from each side, where I get 6x is equal to negative 21. Divide each side by 6. And I'm going to reduce this fraction. 3 will go into both of these. This will be negative 7 halves, or negative 3.5 if you want to make it a decimal. For 76, we can either distribute first, which will give me 6x minus 21 equals 12. Then I'm going to add 21 to each side. So 6x will equal 33. Then I just need to divide each side by 6. Again, I can reduce this. 3 will both go into 33 and into 6. So it becomes 11 over 3. Over 2, I'm sorry. Or 5.5. Because 3 will go into 6 2 times. For 77, we can start by subtracting 3x to each side. So I'm left with negative 5 times 4x plus 3 is going to equal 3x plus 31. I'm going to distribute the 5 to get negative 20x minus 15 equals 3x plus 31. Add 15 to each side. So I'm left with negative 20x equals 3x plus 16. Subtract 3x from each side. Negative 23x equals 16. Then you just divide each side by negative 23. I need to go back and make a correction here. When I added the 15, 15 plus 31 is not 16. 15 plus 31 is 46. So when I divide each side by 23, or negative 23, my x value will be negative 2. For solving the exponential equations, I need to look to see if the bases are the same. They are. They both equal 3. So I just need to bring my exponents and set them equal to each other. X minus 3. X minus 3 is going to equal 5. Add 3 to each side. So we solve x to equal 8. For 79, look at our bases. They are both 2. So just bring my exponents down. 4x equals x minus 4. Subtract x from each side. 3x equals negative 4. Divide each side by 3. So x will equal negative 4/3. For number 80, we can see that our bases are not the same. So remember, we can't make a base any larger. We can only make numbers smaller. So I have 6x to the second, or x minus 2. And I've got to take 1296, and I want to turn it into a base of 6. So I need to pull my calculator out and start doing 6 to the first, 6 to the second, 6 to the third, until I find out what equals 1296. That is going to be 6 to the fourth. At this point, I can see that, yes, my bases are now the same. So I can say x minus 2 is going to equal 4. Add 2 to each side. X will equal 6. 81, we see the same thing. I know that my bases are not the same, so I need to make my base of 5. I'm going to keep 5 to the 2x minus 2 power. And I'm going to turn 6 to 25 into a base of 5. So I start putting in the calculator, 5 to the first, 5 to the second, all the way through. And I find 5 to the fourth to make my bases the same. If I look here, now my 5s are the same. So I have 4 is equal to 2x minus 2. Add 2 to each side. So 6 is equal to 2x. X will be equal to 3. 82, we see that our bases are not the same. So I definitely want to keep 10. And then I just have to figure out 10 to what power equals 10,000. Little hint for base of 10, you count your zeros. 1, 2, 3, 4. So that is 10 to the fourth. Now if I look, my bases are equivalent to one another. So I have 2x minus 1 equals 4. Add 1 to each side. Gives me 2x equals 5. Divide each side by 2. X will equal 5 halves, or 2.5. 83, my bases are the same. I see here that my bases are the same, so I just want to take my exponents. 3x is going to equal negative 2x. I want to get my x's on the same side. So I add 2x to each side. 5x equals 0. Divide each side by 5. So x will equal 0. And that is completely fine for that to happen. For 84, we're going to solve these literal equations. We can see that we're going to solve for L. So the first step that we want to do is divide each side by 2. So I'm left with A over 2 is equal to L plus W. I then want to subtract W from each side, which leaves me with A over 2 minus W equals L. For 85, I want to solve for X. Okay. So I want to subtract 5 from each side. Y minus 5 equals 6x. Divide each side by 6. So y minus 5 divided by 6 is going to equal x. I'm solving for x, which means that I want to subtract 2y from each side. 4x is going to be equal to 16 minus 2y. Divide everything by 4, which is going to give me a simplified answer of x equals 4 minus 1/2 x. 87, we're solving for y. First step is to multiply each side by 2. So 2a will equal x plus y. Trying to get y by itself, so we subtract x from each side. 2a minus x equals y. 88, we're solving for x. So my first step is that I'm going to add by to each side. I have ax equals c plus by. Divide each side by a. So x will equal c plus by divided by a. For 89, I'm solving for c. First thing I'm going to do is multiply each side by 2. I have 2a equals h times b plus c. Now I'm going to divide each side by h, where I have 2a over h is going to equal b plus c. And since I'm solving for c, I want to subtract b from each side, which will give me 2a over h minus b, so equals c. For solving inequalities, we want to treat these like equations. So I start by adding 12 to each side. 4y will be greater than negative 4. Divide each side by 4. Y is greater than negative 1. For 91, I'm going to subtract 7 from each side. I have negative 3x is less than 3. I'm going to divide by a negative 3. Anytime that I divide by a negative, my sign must flip. So I go from a less than sign to a greater than. So x will be greater than negative 1. For 92, we want to start by multiplying each side by negative 3. Anytime I multiply by a negative, I need to flip the sign. So I'm left with 2x plus 6. And so I'm going to use greater than or equal to negative 12. I need to subtract 6 from each side. 2x is greater than or equal to negative 18. Divide by 2. X will be greater than or equal to negative 9. Don't forget, if you multiply by a negative, it's the same thing. You still have to flip your sign. For 93, I'm going to divide each side by 2. I'll have x plus 4 is greater than or equal to 5. Then I need to subtract 4 from each side, so x is greater than or equal to 1. Finally, I want to start by distributing. So I bring down my 2x. Negative 2 times 5 is negative 10. Negative 2 times negative 8 is positive 16x. And greater than or equal to 12 plus 7. I can combine that 12 plus 7 to give me 19. I'm also going to combine my 2x and my 16x. So I have 18x minus 10 is greater than or equal to 19. At this point, I'm going to add 10 to each side. 18x is greater than or equal to 29. Divide each side by 18. X will be greater than or equal to 29 over 18.